Hello, my name is Cindy Yon, and this is my final term project for the Brooks Brainery Summer 2022 program for Biomedical Engineering. So, I am Cindy Yon, as I said, for this fake product. I am the head of design of this company. I am a senior in 12th grade. I plan to become a neuroscientist in the future. My hobbies are drawing. I like to play music. I play clarinet and piano. I like to eat noodles and food in general. So, my problem I'm trying to solve with infinite MRI is that current imaging is too vague. So, what we need in brain imaging to advance neuroscience technology and treatment is that we need to truly understand what is happening in the brain. So we need a more detailed look at the entire brain and what is happening with the communication, the cell signaling happening between each individual neuron, and how it relates to what we are doing, like feeling, seeing, understanding, thinking, doing, movement-wise, and how that relates to ourselves, our bodies, and our brains, and different disorders. So, our current methods have very poor resolution, which is hard for us to create anything new from. Currently, we are at a standstill, well, in quotations, a standstill. Without this kind of technology, we cannot produce better advancements without creating more technology that can allow us to understand better what is happening in the brain and allowing us to develop more research and treatments. So currently, the human brain and what we've gotten to, in 2013, we could image 80% of a zebrafish larvae down to neuronal activity. And nowadays, we can image all of a zebrafish's brain with 3D signals, activity, communication, all of that. But the human brain is much larger, and it's also protected by a skull. So we have 3 to 5-ish issues there. So zebrafish are very small, and they're also transparent. So the way of imaging there will not work for human brains. And also, the human brain is protected by a skull, so that makes them not transparent. And human brains are much larger in cell size and count. So we have to account for all of these things, and then last of all, we have to account for invasiveness of the method, which means that when we do this scanning, will it impact what is happening in the brain, or will it be like a kind of ghost in the cell? So our current techniques are the fMRI, the PET scan, and the CT scan, and the EEG. These are the most famous for brain scans, and I have brief summaries of them all. So the fMRI measures using blood flow and oxygen levels. The information it collects is structural and activity-wise, so it has the vague shape of the brain based on structure, and activity, it detects where the brain is more active based on where oxygen is getting sent more. And fMRIs are used to detect abnormal brain activity and create brain maps for surgeries. PET scans measure glucose levels, so the only information can be gained is activity-wise. Based on the flow of glucose, it shows which part of the brain is gaining more glucose and using more energy, therefore being used more. And it is used to detect Alzheimer's, seizures, and tumors. Then we have CT scans, which are more detailed x-rays, the information gained, the structure, so combined images are used to produce a 3D view of the brain, so they take multiple pictures of the brain in multiple different angles and then mush them together and make a 3D view, and this only shows structure, so you can only see things that cause structural changes in the brain, for example, cancer, brain swelling, or brain injuries. And last of all, we have the EEG, which only shows activity because it only measures in electrical signals produced by the neurons. So it detects brain waves, and usually it's used to measure anxiety, sleep issues, epilepsy, and head injury. few examples of brain scans, you can tell that there is not that much detail within the scans, and they only show very low resolution, low detail results of the brain, which we use to infer things that we know already. So, my problem statement: current brain imaging techniques can show little detail about chemical activity and in vivo activity, which makes it difficult to discover many conditions or produce improved treatments. This product aims to improve brain imaging techniques by measuring neuronal communication and 3D structure, benefiting both the medical and research fields. So, the solution is Infinite MRI. It's basically a brain imaging scan which uses mRNA genetic changes to colorize neurotransmitters in their position. So the syringe will inject mRNA into your body, which will allow it to produce these protein identifiers which attach to the synapse and interact when neurotransmitters attach to the synapse and cause a conformational change, which will then cause a color to be produced which associates with different neurotransmitters. So then, using a color X-ray to detect different wavelengths of light, the scan can effectively categorize different neurotransmitters, activity, and location, which lets us see extremely specific scans that show the communication occurring in the brain between different cells. Combined with the 3D MRI model, the scan can show changes in 3D brain structure and chemical activity, which means currently in 2021 there was a new brain scan developed, which is currently going through testing. It is using vibrations in the brain to create a 3D model of the brain to show structural changes and how the brain moves inside the skull. So that can be used to judge many different types of disorders, because different movements in the brain indicate different disorders. So we will also combine this scan with one of those to make it most effective and practical. So the performance metrics: the syringe is extremely biocompatible, and you can think of it like the COVID vaccine, which also uses mRNA. You will be a bit sore, and it will only last for the amount of time required to do the scan or required for the user to view the information for in vivo. So if they needed you to look at a couple pictures for an hour, then they would scan your brain continuously and as you view the pictures. The syringe will only ever be used when it's in a sterile environment, so it is contained in a sterile environment with packaging, and once that packaging is opened, it should be immediately used and then disposed of. Just like a normal syringe, it is also single use and follows all normal syringe rules, and the scanner is multiple use friendly and very movement friendly. It requires energy and should be plugged into a wall to be used. Our engineering characteristics: the scanner is 60 centimeters long, 130 centimeters in width, and 140 centimeters in height. It's around 530 kilograms, and it is very transportable. It's got wheels, and it doesn't fit too well through doors, so probably double doors would be best, but it is very portable in a hospital environment, and that is the goal we're trying to reach. We are going to use a 22 gauge 1.5 inch syringe, which is around the normal size for a syringe. The X-ray is made of a plastic surrounding around the outside with a metal shield in the inside, and a glass tube and a lead casing, which protects from radiation, since glass and lead are very good radiation barriers. And these protect the scanner. Well, the metal and the plastic protect the scanner, while the glass tube and lead casing protect the patient and the users from too much radiation poisoning. Then within the scanner, we have a photon counting detector, which allows the X-ray to view more wavelengths of color, which allows the AI software to view better colorization. Wavelengths will be viewed by the scanner, and those multiple different wavelengths will be categorized by the AI software and colorized in the software. So there will be one version which is the black and white version and one version which is the colorized version. There are multiple different options you can choose from, but the AI software will categorize the data for you, put it in an easily movable 3D image, and you will be able to view in color all the different parts of the brain and how interaction is occurring. So the X-ray is easily transportable, and like I said, it can be stored anywhere. It's mostly very easy to use within a hospital. So our market, we expect this to be a billion-dollar market because it affects so many people and many people can use it. The infinite MRI is used by imaging technicians, neurologists, and psychiatrists in a medical location to analyze the brain and discover conditions. It can be used to discover new ways of finding conditions, maybe earlier or in a new light, an easier way to find a condition in the brain. And in a research location, all researchers are able to use infinite MRI to view highly detailed interactions between each neuron in the brain. So understanding the breadth of neuronal communication allows for scientists to produce better treatments and improve understanding of mental disorders. So in a research environment, this new information can allow them to produce better treatments, and we can improve the public understanding of mental disorders and their science behind it. The people affected, there are so many people affected. Almost everyone can name at least one person who has a mental disorder or mental illness. So, for example, over 11 million Americans have Alzheimer's disease, and this is only one portion of the affected, and it's only in America, so you can imagine the possibility, the width of the market. There are so many different things you could use infinite MRI for, and it is cut off, but the development of improved treatments, better understanding of mental illness and disease, earlier discovery of conditions like Alzheimer's and dementia, where faster treatment can much improve the condition further on in life. And learning details from disorders mostly unknown. Like autism, we don't know too much about autism, and there is no treatment. So people who have autism are just required to live with it, and we are still doing so much studying into it, and there is not that much that we know. So, the distribution and implementation. We will start with creation, and we will do an experiment and test the scanner on a sample of 1,000 people with many varying mental conditions, and this will mostly be to measure safety and accuracy of the scanner, and then we will move on to a larger test before we send it out for mass production. Then production, we expect it to be a class 2 product. It will be slightly dangerous since it is an X-ray and a syringe, but it will not be up to class 3 level. The product will be made in an assembly line for mass production, the scanner. The biomedical engineer professionals will review the scanners to see if they are fit for public use. Then computer scientists will produce data collection software and AI for colorization and easier viewing of the communication occurring within the brain. And usage, experienced technicians will operate the X-ray and will work with doctors to analyze the data. They will, just like any scanner in a hospital, doctors and technicians will work together to understand what is occurring, and researchers will work with technicians to view different scans and how it functions for different disorders. So, advertisement, We will promote to researchers first, who can spread the word through papers and mouth before we reach a much wider audience to ensure that nothing extremely goes wrong at first. Then we will move to the medical field and then promote it through lectures and hospital sponsors, and we will do giveaways. Lastly, the closing. As mental illness and disease rise, these disorders become an ever-increasing cause of death. Most everyone can name someone who's affected by a mental disorder. New information about how neurons communicate helps improve treatments, therapies, and identification of these life-changing conditions. Infinite MRI has many benefits, but most noticeably, it revolutionizes brain imaging and the field of neuroscience. Understanding the brain is quickly becoming the new human genome project. With Infinite MRI, new groundbreaking information can be learned about the brains, which means we grow a little closer to understanding ourselves. Thank you for coming to listen to this video. I hope you have a great day, and I hope Infinite MRI has intrigued you in some way, and you can create your own fake invention and have fun with it. Have a nice day.